And we are on our last factoring review. Remember how important it is right now to work through this. I hope that you are going to stop this on the next slide and make sure that you do all 10 problems and then come back to check in just a moment. All right, let's get started. Here is the list of problems. Go ahead and factor every single problem completely. Now, completely means that you're going to have more than one thing to do, and in some cases, you have 2 or 3 things to do. Pause and come back in just a moment. All right, let's get busy. Number 113. The first thing I have to do is take out a greatest common factor of 4. That leaves me with x squared minus 16. This is a difference of 2 squares, so that's going to be x plus 4 and x minus 4. At this point, I have no exponents that are even, so I would be finished with this problem. Number 114. The first thing I notice is I have a GCF, so I'm going to take out 3, and I see that it has a b to the third. Everyone has a b to the third, so that's 3b to the third. That leaves b squared minus 2b minus 8. Now I need to see what multiplies to give me negative 8 and adds to give me 2. This is a trinomial. It's an easy trinomial that requires no work because it does not have a number in front. I need a b here and a b here. I need to multiply to get 8 and add to get 2. That is 4 times 2. The 4 is going to be negative, so that the 2 will end up negative, and that 2 is positive. That's your final answer. Number 115. The first thing I always have to try is GCF. I notice that they both have an a squared, and they also both have a b to the third. Now I'm going to have to subtract exponents as I work through this. I need 4. I have 2 out here. That leaves a squared. This is b third. That's a b third, so I don't need any additional b's. On the second part, I took out an a squared here, so I don't need any more a squares. This is a b to the fifth. I took out 3, so I have b squared left. Looking at this, this is the difference of 2 squares. So I'm going to rewrite my greatest common factor. Difference of squares has 2 parentheses, 2 terms, and 2 different signs. A squared is a times a, and b squared is b times b. I'm finished. There's nothing else I can do. Good job. 116. This one is that awesome problem I was telling you about today. The first thing I always need to try is GCF. They both have t to the fourth. When I take out t to the fourth, I'm left with 16 and then minus 1. This is a difference of 2 squares. Leave the t to the fourth and break this into 2 parts. T to the 8th plus 1 and t to the 8th minus 1. Now this plus 1 is the sum of 2 squares, and we don't have any factoring for that one's done. This t to the fourth is finished, but this t to the 8th minus 1 will go again. That's going to be t to the fourth plus 1 and t to the fourth minus 1. I've got to bring down my GCF and my sum of 2 squares. This one's done, this one's finished, this one's complete. However, this t to the fourth minus 1 will go again. So that's t to the fourth, t to the 8th plus 1, t to the fourth plus 1. I've got to split t to the fourth in 2 parts, t squared plus 1 and t squared minus 1. All right, finished, 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 and happy, happy, joy, joy. This one will go again. So that leaves me with t to the fourth, t to the 8th plus 1, t to the fourth plus 1, t to the second plus 1, and then finally t plus 1 and t minus 1. Now, wasn't that fun? Again, these are even exponents, but they cannot go again because there's a plus sign. This one's finished, and this one is finished because the exponent is 1, and we cannot do any more. All right, that one's finally finished. Number 117, I noticed there is a greatest common factor, so I'm taking out a 5. There's no number in front, so this is a very simple factoring problem. Multiply to get -3 and add to get 4. Okay, that would be 3 and 1. That's the final thing I can do right there because they multiply to give me 3 and add to give me 4. Final answer. Number 118, I noticed they also have perfect squares, but the 2 and the 550 have something in common. They both have a 2. They also both have an x squared. That's going to give me x to the second, because 2 and 2 is 4, minus 25. I took out the x squares. Now I have the difference of 2 squares, so that's going to be 2x squared, x plus 5, and x minus 5. Final answer. Okay, this has 4 terms. Since it has 4 terms, it's going to be a grouping problem. I'm going to divide and conquer. Take an 8 out here, and we're left with t plus 4. On the second term, we can take a 2 out and an s out, and we're left with t plus 4. Well, isn't that convenient? Both of those have a t plus 4, and left over is 8 plus 2s. Now, we've never had a problem like this before, but since this 8 and the 2s both have a greatest common factor, we need to take out a greatest common factor. These have a 2 in common, so I'm going to write the 2 down. That leaves me with 4 plus s. I also need to write down my t plus 4. If this bothers you because it's backwards, you can just make it s plus 4 and t plus 4. Number 120, they all have a greatest common factor. I believe it is a 5. And what letter? An m. So that gives me 5m squared minus, let's see, 5 goes into 90. My little guy's not showing up here. I don't know why. Hold on, guys. And that divides 18 times. 5 goes into 40, 5 goes into 40 8 times. All right, now I have a number in front that makes it a slip and slide. So I'm going to rewrite my 5m. I'm going to slip the 5 down here to the 8. So that gives me m squared minus 18m minus 40. Multiply to give me 40, add to give me 18. So you would just go 2 times 20, making a list. Oh yeah, that works. So that's 5m, m minus 20 to make it a negative 18, and m plus 2. Now I need to take the 5 that I slipped and slide it back under. That gives me 5m, m minus 4, and 5m plus 2. Next problem, number 121. This has 4 terms, so I need to divide and conquer. I can take out, let's see, both of these would have an 8 in common. Oh, you know what? I think they have a 16 in common. You always have to go with the highest and an x to the third. So that leaves me with 2x minus 3. Now I need to look at the second term. These both have a 4 in common and an x. That leaves me with 2x minus 3. Isn't that wonderful? Okay, now I'm going to take out the 2x minus 3, and I have left over 16x to the third plus 4x. Now you can't have anything left inside here, so I'm going to do a greatest common factor. They both have a 4 and an x. That leaves me with 4x squared plus 1, and I also need to write down the 2x minus 3. That would be the final answer. Number 122, I notice these also have a greatest common factor of a 6, an s squared, and a t. All right, let's do some subtracting while we work on this. 4 take away 2 is s squared. We already have the t. 6 times 2 is 12. Here's an s to the third and an s squared. That leaves me with an s. The t squared and the t, I have a t left. 1 goes on the end. I have an s squared already pulled out. This was a t to the third. I took out a t, so that leaves me with t squared. So I have 6s squared t. Now if you notice, this is a perfect square and this is a perfect square. So I'm pretty sure this is going to be a perfect square trinomial. I'm going to try it and see if it works. S squared gives me an s. T squared, I can fill in a t, plus sign n squared. Now let's see if that works. S times t is st. And if I double that, it gives me 2st. Final answer. All right, one problem last, and then we get a joke. This is divide and conquer, which is grouping. The 10 and the 4 have a 2m squared in common. That leaves me with 5m plus 2. With the minus, I'm going to have to take out the negative. So this is going to leave me with, let's see, I can take a 9 out, I believe. No, I can take an 18. That leaves me with 5m plus 2. This 5m plus 2 is going to go out front. And I have left 2m squared minus 18. I see a greatest common factor in here, so I'm going to take out a 2. And I'm left with m squared minus 9. I need to bring back my 5m plus 2. Now I see right here that this m squared is another difference of two squares. So I'm going to drop down my 2, change m squared minus 9 to m plus 3 and m minus 3, and bring down my 5m plus 2. All right, great job. You need to study some of these problems if you had a hard time with them the first time through. Now let's hear our joke. What did polynomial call her spoiled triplets? Think, think, think. The perfect trinomials. Well, thank you for joining me tonight. I hope you had a great time, and I hope you do a lot of practicing and preparing for your next test. I will be there at 6:40 in the morning. Thank you so much for being here, and good night.